Polynomial divisions is very similar to regular divisions. Let's say we have number 15 and we want to divide it by 2. Basically, here we will have um, 2 multiplied by 7 plus 1. So if we multiply 15 by 2, the factor that we can get out of it is 7, and the remainder will be equal to 1. The same way is a polynomial. So if we have the polynomial of f of x and we are doing the division, so we will have, let's say, qx g of x plus rx. Rx will be our remainder, g of x is the divisor, and qx is our quotient. Now, one important note is that the remainder is always, the degree of the remainder is always less than the degree of our quotient. Now let's go over and do one example. Let's say that we have the function 3x cubed plus 4x plus 11. And we want to divide this by x squared minus 3x plus 2. So the very first thing that we need to learn is how to write the long division. So the first thing is that we write the function that we want to get divided by on the left side. So we write x squared minus 3x plus 2. Then we will have the 3x cubed plus 4x plus 11 down here. And now here is going to go our quotient. So that's the divisor, and this is our function, the polynomial, and the quotient goes on the top. So we got the highest degree is x cubed with the coefficient of 3. So we need to match the highest degree here with what we have over here. So we have x squared, and that's x cubed. So we need to multiply the whole function, the whole divisor by x. And also the coefficient need to match. So we put a 3x over here. So we multiply the whole thing by 3x and we write it down here. So it's going to be 3x to the third minus 3x by minus 3x is going to be 9x squared. 9x squared. And then we have plus 2, 6x. Plus 6x. And then we subtract this from that. So the first one, that's what we were looking to get canceled. It gets canceled. 3x to the third, 3x to the third gets canceled. Now we have a second degree and a first degree. But here we only have a first degree and a number. So when we do the subtraction, that's negative multiplied by a negative, we get 9x squared. Then the 6x and 4x, they get added. So it becomes negative. So it's going to be minus 2x and then plus 11. Now we do the whole thing again. So here we have 9x squared. So let me change the color. So we have 9x squared and we want to match it with that. What do we get? We get only the value of, we are missing only a 9. So that's going to be plus 9. So if we multiply the whole thing by 9, so it's going to be 9x squared minus 27x plus 18. And we do the same thing here. That's going to be a negative. So these two, they get canceled out. And then we have here the remainder, which is 25x, well, the negative, positive 27 minus 20 minus 2x, 25x, negative 18 plus 11 is going to be minus 7. And that's it. So we are done. So here our quotient is 3x plus 9. Our remainder is 25x minus 7. And that's the end of it. That's how we do the long division. So there are two theorems that we can derive from long division or any polynomial division. And one is a remainder theorem and the other one is the factor theorem. The remainder theorem says that if we have f of x is equal to x minus a q of x plus rx. And the remainder theorem says that if the f of x is divided by x minus a, then the remainder is going to be f of a. So that means that let's do an example and see what it means. So if we have x of x to the 4 plus x to the third minus 7x minus 10, and that's our f of x. Let me write it. F of x is equal to that. And we want to divide it by x minus 2. We can do the long division and get the remainder to see what the remainder is. But if we are said that this is divisible by x minus 2, we say that the remainder Rx is equal to f of 2. And that is going to be equal to what? 2 to the 4th plus 2 to the 3rd minus 7 multiplied by 2 minus 10. We do the simplification and the answer is 0, which means that if we divide f of x by x minus 2, our remainder is going to be equal to 0. Let's go ahead and do the division to see if that is actually correct. So we have, let me write it over here. So we have x minus 2. And our function is x to the 4 plus x to the 3 minus 7x minus 10. So first degree, fourth degree, no coefficient, so x to the 3rd. So x to the 4th minus 2x cubed. That gets canceled out. This one becomes positive. Then we will have 3x, 3x cubed minus 7x minus 10. Now the next one is a second degree. So plus, the coefficient is 3x squared. And now we do it. So it's going to get 3x cubed and then that multiplied by negative 2. So it becomes minus 6x to the second. Then this one gets cancelled. Remember, over here, we are subtracting. So that one gets a -1 behind it. So this one becomes positive 6x, and it comes out. So 6x squared minus 7x minus 10. Now the next one is going to be 6x. So if you multiply this by 6x, we get 6x squared minus 12x. That gets canceled out. That one becomes plus 12. The remainder is going to be 5x minus 10. The next one is going to be only a 5. So 5 multiplied by x minus 2, 5x minus 10. And what's the remainder? So if you put a negative here, this is going to get canceled out. This is going to get canceled out. The remainder is 0. So that, the long division, we got the remainder 0. We just we knew that x minus 2, that's the divisor, and we are doing the division by that. So 2 is a factor. We put the 2 in the function, and we got the remainder equal to 0. So now this was the remainder theorem. The factor theorem is derived from the remainder theorem and says that the value of the a, whatever it is the root of the polynomial exactly when the root is equal to 0. So it's basically the opposite of the root theorem. So if we know that the root is equal to 0, so x minus a is the factor and a is the root of the polynomial. So that means if Rx is equal to f of a is equal to 0, then f of x is equal to x minus a times q of x. Because we already know that if that's the root and that's the factor, the remainder is going to be equal to 0. Okay, now let's go ahead and do one example to see how it plays. So we are given a function f of x is equal to 2x to the fourth plus 7x to the third minus 4x to the second minus 27x minus 18. And we are asked to show x minus 2 is a factor of f of x. So if we want to show that that's the factor, we can do the division. The long division, we can do it. And if the remainder is 0, we know that that's a factor of it. Or what we can do is to use the theorem that we just learned. And that states that if the Rx, which is the remainder, which we said is equal to f of a is equal to 0, then x minus a is the factor. So here a is equal to 2. So we plug it into the function, and if the answer is equal to 0, then x minus 2 is a factor. So f of 2 is equal to what? 2 times 2 to the 4 plus 7, 2 to the third minus 4, 2 to the second minus 27 times 2 minus 18. Up, plug it into the calculator or do it by hand, and the answer is 0. And that proves that the remainder is 0, so x minus 2 is a factor of f of x. Now we move to synthetic division. Synthetic division is a simpler form of long division when we have x minus a as the factor of a polynomial. And how do we do the synthetic division? It can be a little bit difficult to understand, but once you learn it and once you get the grab of it, it's pretty easy and it's fast. So let's say that we have, I'll go over it with one example. So if we have the function f of x, or polynomial, is equal to x to the third plus x to the second minus 1. And the factor we want to divide it by is x minus 1. So the way that we use the synthetic division is we use the coefficients. So we don't write the x's, just the coefficient of the polynomial that we have. So how do we do it? So I write 1 for x to the third. Then that's the highest degree of the polynomial. Then the next one is x squared, and the coefficient is 1. Then the next one should be x to the power of 1. I don't have that here. So that means the coefficient is equal to 0. I write it down. I have to write all the degrees. Then the next one is x to the 0 with the coefficient of negative 1. So that's the f of x, and I'll write it on the first row. Then on the left side, what I want to get divided by, my divisor, x minus 1. I don't need the degree of 1. I just need basically the root value. And that's, or the value of the a. And that's equal to 1. And I want to do the division, right? So the way that we do the synthetic division is that the first or the highest degree coefficient automatically comes down. Then I multiply my a value by that coefficient. So that comes down. I multiply it, and then what do? I add it to the value of the next one, and then I write it down. So it's 1 times 1 is 1. Then I add it to that, and then it comes down as a 2. Then the next one is going to be what? So the next one is going to be 1 multiplied by 2. So this is always multiplication, and here is the addition. So 1 by 2 plus 0 gives me a 2. Then the next one will be what? The next one is going to be again 1 getting multiplied by 2 plus negative 1. So 2 plus negative 1 is going to give me a 1. So now if I want to write the values that I have for the multiplication here, I can do that too. So we say 1 by 1, so that was a 1. 1 by 2, that was a 2. 1 by 2 was a 2. So I had a 1, 2, 2 from the multiplication, and then the additions get here. And these four are the final answers. That's it. We are done with the synthetic division. Now figuring out how to write it. So here I have a degree of 3, and I have the divisor degree of 1, right? So my quotient is going to have a degree of 2. And that's the first coefficient of it. So it's going to be x squared 1 plus, then I have a 2 x to the power of 1 plus 2 x to the power of 0. And that's the quotient. So my quotient is that, which if I simplify, it's going to be x squared plus 2x plus 2. And the last digit that I have here is going to be my remainder. So r of x is equal to 1. And that's how I get this synthetic division. Now let's go ahead and do one more example. We will do the same problem that we had for the previous part, and we did the long division. Here we will do the same division using synthetic division. All right, let me write it down. Our f of x was equal to x to the fourth plus x to the third minus 7x minus 10. And we wanted to divide it by x minus 2. Now let's write it down. We said that we write only the coefficient. So 1, 1, we are missing x squared. So that's 0. Then I have negative 7. And then I have negative 10. Then my a value is 2, right? So we said this is how we do the division. We said that the first one, the first coefficient, the highest degree of our polynomial coefficient comes down automatically. So I have a 1. I multiply 2 by 1 and I write it here, right? So 2 multiplied by 1, 2. And then I add these 2. So it becomes 3. 2 multiplied by 3, and I write it here. It's 6. And then I add them. And then I got 6. 2 multiplied by 6 is 12. I write it and add it together. 12 minus 7 is 5. 2 multiplied by 5 is 10. And I add these together and I get a 0. If you remember, the remainder of this division was a 0. And we said that the last digit in our synthetic division is r. This is equal to rx. And this is our quotient. So if I want to write it, what's going to be? So this is degree of 4. So I'm going to have 1 degree less, which is going to be x to the third. My coefficient is 1. So the next one is 3. I go 1 by 1 down. So x to the second here plus 6x plus 5. And this is my q of x. So that's f of x. That's my divisor. This is the quotient, and that's my remainder. So if you see, doing the synthetic division is pretty easy, straightforward, and fast. And you can get the remainder and the quotient from it in just one step, basically.